Hello there, hello world. Yeah, actually I am recording with my selfie camera for my cell phone, and that's pretty good, eh? Yes, if you asking, it's Christmas. No, it's not Christmas. Actually, I don't know what is the date, but in camera is going to appear. This is the date. So, anyways, hello. This is an introduction from. That's this. So, have you seen electronic cars or self-driving cars? Yeah, a car who drives itself. That's crazy, right? That's awesome. It's just a car who drives itself alone. You will not doing anything. You will not do anything, and it will drive alone. It with life drives itself. So we're going to make a small car and this small car is going to follow a black line. It's called a follower from black lines. It with sensors and resistance in a proto board. Yeah. So enjoy the video and please subscribe if maybe this video is going to be in YouTube, and put below the like, and that's all. Have a nice day, have a great time. My name is Johan, and see you in the next video.
Objective. The main objective of this project are: present the basic theory and practice to make the lane follower car, introduce fundamental concepts as well as provide basic information to understand the circuit, see the operation of each electronic component and device, interpret the schematic diagrams that were developed during the work, and show the practice of the theoretical principles that are transmitted.
Materials: C74 LS32 or C74 LS18 and C74 LS4 not. 4 resistor of 270 ohms. 4 resistor of 1K ohms. 4 transistors 2N2222A. 2 transistors BC547. 1 transistor BC548. Diodes 1N4007. 1 battery of 9 volts. Jumper cables. 2 test engines of 9 volts. 4 switches. 4 LEDs. 4 resistors of 220 ohms. 4 electric alligators. Battery holder clip for battery of 9 volts. 2 protoboard.
Procedure. Well, the procedure consists of: first, we have the truth table. This truth table will be simplified from kernel maps. Before continuing, I would like to clarify that entries that are 0 will be represented by a quotation mark. For entries that are 1, Pay will have no quotation mark. For the first output, for example, what we have to do is to record the number of each possible case. So we have in the first case a 1. Observe this, we record the numbers that are in trees in the kernel map. This step will be performed until the table is filed. Once the table is filed, we sort in each kernel map. Attach it with 2 links to make kernel maps.
Arno maps with 4 variables. Here's a truth table with 4.
Okay, so as you can see on the screen, we have
And we obtain the expressions of each output. This is the schematic diagram, which was made with logic gates based on the expressions of each output.
Today, I am going to display the connection diagram of the line follower carrier. The first thing we can see in this diagram from left to right are the LEDs that go to the switches and have their respective resistor. This LED indicates the input. When any switch is activated, it sends a volt that can be interpreted as 1. Switch is directed to the input of the integrated circuit. The internal representation of each integrated circuit will appear on the screen. And according to this representation will be connected according to the gate diagram. Another clarification is that the volt pins of each integrated circuit have 2 resistors of 220 ohms. Since the resistor makes only 5 volts array. Then the final output on the logic gate the circuit are connected to the edge jumpers, and clarification is that the edge jumpers are to change the direction of rotation of the motor. For example, the output E and F are connected to the first edge jumper, and the same cache for the output G and H in the second edge jumper. The final will left and video in switch in the circuit representation already made.
Applications. It can be applied in the industry for internal transport tasks in warehouses, towing heavy equipment, tournaments called road work, image processing, transport, interactive game, and book finder in a library.
Conclusion. As we could observe throughout this report, the line follow car is, first of all, a project that allows us to start in the world of robotics, being this as the hello world of programming. It also always us to observe the behavior of a car that does not need someone to control it. In short, it can be considered automation in miniature. In this small project, we cover the procedure that was performed, as well as a description of basic components with which the robot works. To show the importance of this type of robots, we have shown their purpose of as well as their different applications in different areas of human in the world. That side, we recommend to make one if you want to start in the study of the different fields that modern industries offer us.